All right, welcome back. Our next problem today is to find the area, not of the whole circle, but just of a sector, which is a slice or section of the circle. So find the areas of the sectors formed by angle PSQ. All right, so kind of like how we looked at arc lengths as a portion or fraction of the total circumference, we can look at areas of sectors as a portion or fraction of the entire area of a circle. Okay? And because we're dealing with portions or fractions, we're going to use ratios and proportions. All right, so when I printed this problem, it came out obviously grayscale, but on the computer, this section here is pink. And then the other section is blue. I'll color that one in later because I just want to focus on this pink sector. Okay. So the area of a sector is a portion of the total area of the circle. Okay. So let's say area of the sector is a portion or fraction of the area of the whole circle. I'm just using the symbol of a circle. Okay. But these sectors, right, are associated with some central angle, right? And so we can look at the central angle of that pink sector, which is 135 degrees, as a portion of the entire central angle we could make, which is 360 degrees. So we're just setting up ratios, right? A ratio of areas and then a ratio of central angles. And then we're going to do some solving. Okay. Now, obviously, I can't solve this if I have two unknowns. So I've got to solve for one of these. So I got to figure out one of them first. And I can figure out the area of the whole circle, right? Because I have the radius and I know the area of a circle is pi r squared. So then I'm just going to have the area. Let me just call that x because I don't want to write the whole thing. So we'll call that x. Okay, so the area of the sector, x, is a ratio, is a portion of the entire area of the circle, and that's pi r squared. And then that is proportional to the central angles, 135 and 360. Okay, I'm not writing the degree symbol anymore. Okay, now the radius we know is 15, so we're going to have x over pi times 15 squared is 135 over 360. And then we'll just use our calculator now. 15 squared, I want to say it's like 225. Yep, it is 225. Okay, so x over 225 pi is equal to 135 over 360. And then we are going to multiply, we're solving for x. X is the area of our sector. And so to isolate x, we can multiply both sides of our equation by 225 pi. Okay, so it's going to cancel on the left-hand side. And so we get x, which is the area of our sector, is equal to 135 times 225 pi over 360. Okay, let's try to start simplifying that. No, let's just use a calculator. So 135 times 225 divided by 360. Oh, that doesn't come out to a nice looking number. Okay, so let's reduce. Okay, let's see. I know that 360 is divisible by 5. It's 72. And 225 is divisible by 5. It's 45. Okay, let's see. 72 is divisible by 3. It's 24. 45 is divisible by 3, it's 15. Let's see, those are both divisible by 3 again. 24 divided by 3 is 8, and 15 divided by 3 is 5. And 8 is divisible by 2 or 4, and none of those are divisible by 2 or 4. Okay, so what we end up with, after all that simplifying and reducing, we have x is equal to 135 times 5 times pi. So that's 675 pi over 8. And then, and this is going to be centimeters squared, right? Because the units of area are squared units. And then if you just want to get it to like a decimal value, use your calculator now. So 675 times approximately 3.14 divided by 8. So we get x is approximately 265 centimeters squared. Okay, so I was doing all the calculations off screen on my calculator. Okay, let's do that again, but we'll do it for this bigger sector. Okay, so let me color code this blue. Okay. So remember, if we were to make an entire central angle, that'd be 360, but the pink central angle is 135, so the blue one is just going to be the difference. Okay. So 360 minus, what is it, 135, that's going to be 225 degrees. Okay, so let's see how well this shows up. 225 degrees. Okay. And then we're going to use the same kind of proportional thinking, right? The ratio of the blue area to the total area is equal to the ratio of the central angles. So let me call this area there y. Okay. So y is the area of the blue sector, and that is a portion of the whole circle, right? So the area of the whole circle. Right? But that ratio is equal to the ratio of the angles. And so the central angle of that blue sector is 225 degrees, and the central angle for the whole circle would be 360 degrees. Okay. All right, so the area of the whole circle, we calculated that, you know, in the first problem, it's 225 pi. So we have y over 225 pi is equal to, okay, 225 over 360. Okay. And then we're just going to solve for y now. So multiply both sides by 225 pi. Okay, so y is equal to 225 times 225 times pi, all divided by 360. Okay, my brain is kind of fried at this point, and I don't feel like trying to reduce that fraction, so I'm just going to convert it to a decimal value right now. Okay, so 225 times 225 times pi, which the calculator's, you know, 3.14 more or less, divided by 360, it comes out to roughly 441.8. And this is an area, so it's going to be squared units, centimeters squared. Okay. All right, thanks for watching. I'll see you next time.